So this is part 2 of the differentiation video series. And in this video, we're going to be looking at differentiating exponentials and log terms, more specifically natural log terms, i.e. learned terms. So you can see on the page that I've written out how we differentiate an exponential term and how to differentiate a learned term. But this is a formulas they give you in the textbook, but rather than this, I think it's better to learn it as, if we have y is equal to e to, rather than k, I'm going to write it as a function of x. So it could be any function. Then when we differentiate this, we differentiate this function, so we get f prime of x, and we bring it to the front, and you multiply 2e f of x. So the power f of x never changes, it's just that we differentiate the function in the power and then you multiply it to the front. It's a better way forward and lets you know how to differentiate all different types of exponential equations. Same thing with the natural learned term. So if I have y is equal to learn, rather than x, I'm going to write it as a function of x. And if I was to differentiate this, then it automatically becomes a fraction, where the function x becomes the denominator, and the derivative of that function becomes the numerator. So whenever we differentiate a learned term, it always becomes a fraction. So with this too, you can actually differentiate anything you want. So let's say I have y is equal to e to the, let's start off with simple 2x. In our scenario, our f of x is equal to 2x. And so what we need to do is differentiate that, which means we get 2 and we bring it to the front. So it's dy by dx is equal to the derivative, which is 2e to x, like this. It's very simple, right? Let's think of, we can even do, let's say y is equal to e to the sine x. We know that when we differentiate sine x, we get cos x, right? So our function once again is sine x. If we differentiate that, we get cos x. And so the derivative of e sine x will become cos x times e to the sine x. Okay, so as long as you know this equation, the rule, then you can just about differentiate any exponential term you want. Let's take a look at some examples for the natural log term. So let's say we have y is equal to learn 2x. So dy by dx, remember, is automatically a fraction, right? So the function, in our case 2x, goes to the denominator, and the derivative of that function becomes a numerator. So differentiating 2x, just 2. So it's 2 over 2x, which means it's just 1 over x, like this. What about if we did y is equal to ln 4x? Same thing, dy by dx is equal to, our function, in this case 4x, goes to the bottom, the derivative is 4, and so that cancels to x. So in fact, if it's just some constant times x, then it's automatically when we differentiate it 1 over x. It's slightly different if it's not something times x. So for example, if I said, let's differentiate it ln x squared plus 2. So dy by dx, automatically a fraction. The function goes to the denominator, so x squared plus 2 goes to the bottom. We differentiate the top, so we get x squared is 2x. So this is now the derivative of ln x squared plus 2. Let's try one more. So let's say y is equal to ln sine x. Okay, so dy by dx is equal to sine x goes to the bottom, differentiating sine x goes to the top, so its derivative of sine x is cos x. So it'll be cos over sine, which we can simplify to cot x, which we've learned before. So as long as you know the two rules for differentiating an exponential term and a natural log term, then you can just about differentiate anything you want. Right, moving on. There are also other exponential forms, because it doesn't always have to be in terms of e, right? It can be in terms of, an exponential is just anything like y is 2 to the x is also an exponential. So ideally you want to be able to differentiate all types of exponential, because that rule, what we learned before, is only for e. So let's say, I'm going to say I want to differentiate a to the x, where a is any value it could possibly be, right? So the way we differentiate it is, you need to know this proof as well, so make sure you understand how we go step by step. Well, first of all, what we're going to do is we're going to write it as y is equal to e to the ln a to the x, like this. But remember, e to the ln x is the same thing as x, right? So in our case, our x is a to the x. So it's still the same value, it's just that we've written it in a slightly different form. The reason why I've done this is if I now use the log rule, this is the power, right? So I can say this is equal to e to the x ln a, like so. The reason why I've done this is because we're trying to differentiate it, right? And so if we change it into e base, that means we know how to differentiate e terms, right? Because we looked at the equation before. So in our case, our function for differentiating e is x ln a. And so if we were to differentiate that, then remember a is a value, right? Any constant value. So ln a is automatically a number. So it's just imagining like differentiating like 2x or 3x. It's just get rid of x, right? So what we get is just ln a when we differentiate this. And so the derivative of e to the x ln a is ln a multiplied by e to the x ln a, like so. And now it's just going back in reverse. So this, remember, we said it's the same thing as this here, right? So I can say that it's equal to a to the x ln a. Okay, so the derivative, if we have a form y is a to the x, the derivative of that is a to the x ln a. So this is another equation. It's not in the formula book yet, but it's an equation that you should be aware of. And you also need to know the proof, how we just proved it just like here. So this means that, for example, if we go back to this, oh, I want to differentiate y is 2 to the x, right? You just have to identify what a value is. In this case, a is 2. So if I differentiate it, just replace the a with 2. So it's going to be 2 to the x ln 2, like this. Simple as that. All right. They might also ask you to say, what is the derivative of y is equal to a to the kx, like this, where there's a constant value k. In this case, I want you guys to try it yourselves and then leave it in the comment section below, and then we can check it out later on. So let's just try and do some more questions. So let's say I have y is equal to e to the 2x minus e to the minus 2x squared. And I want to differentiate this, okay? So it may look a bit daunting when you first see it, but just it's step by step, okay? So first things first, we expand the bracket. So this becomes e to the 4x plus e to the minus 4x minus 2, just expanding the bracket. And now, once we've done that, now we can differentiate each term. So e to the 4x is 4e to the 4x. Differentiating this second term, be negative 4e to the negative 4x. And differentiating minus 2, well, that just is a number, right? So it just disappears. So as long as you know the rules, then you can just about differentiate anything. Right, let's take another question. So let's say I have y is equal to 2 to the 10x plus 8 to the x divided by 4 to the 2x. This might seem daunting to you at first glance, but it's just, we've learned the rules, so it should be fairly simple. We just need to make it into something we recognize, okay? So as you can see, they all have different bases. So ideally, I want to make them to the same base, as we know that 2 cubed is 8 and 2 squared is 4. So just using the indices rules, I can say that this is equal to 2 to the 10x plus 2 to the 3x over 2 to the 4x, which once again reduces to 2 to the 6x plus 2 to the negative x, like this. Now we've written it in this form, it's more recognizable, right? And so we can differentiate it because we've learned how to differentiate y is a to the x as well, okay? So this becomes 2 to the 6x times 6 ln 2 minus 2 to the negative x ln 2, like this. This first part is a hint of, remember when I asked you to try and prove how to differentiate y is a to the kx? This is a hint of what something similar what you should be getting when you differentiate this term here. So that's all the exponentials and the natural log terms differentiation. We'll be looking next at how to differentiate using the chain rule and the product rule and the quotient rule.